This is Miss Morrell talking. We are going to be on page 5 of your packet, and should be week 2. And you're doing this when you are not at school or when you are on your off day. Okay, so today we're going to talk about equations. Okay, so equations, and this should say are about, not is, because it's plural, are about deciding. So deciding means we're going to make a decision, I don't know, if two sides or two amounts, so like two numbers really, are the same. Okay. So to decide about an equation, we first need to know what an equation is. So an equation is two expressions connected with an equal sign. That's an I with. Okay, an equal sign is just that, equals with the two lines. Okay, now there's 3 types of equations when we work on this. Okay, there's going to be a true equation, a false equation, and an open equation. So a true equation is when both sides are the same. So it's actually equal. Okay? A false equation is when the sides are different. So we're going to use this equal sign, and then we put a slash through it. That says it's not equal. Okay? Now an open equation, it means that there is an unknown okay? An unknown in math, we generally use a variable. So we don't know what the variable is for or what number it could be. It could represent 2, it could represent -3. We just don't know. Okay, so we're moving on to our examples here. This one says to identify the following as an equation or an expression. So an equation, really we're focused on that equal sign. So equation, equal sign. Okay, an expression is just going to be just some math without that equal sign. Okay, so here we have 2x plus 17. I notice there's a variable here, there's an operation, we have adding, but there's no equal sign, and we're not sure what this could even equal because we don't know what x is. So this is an expression because there's no equal sign. It's just one part. It's just some math. I don't know if that's the proper term, probably. Okay, here on this one, number 2, I see I have 34x plus 2y equals 12a plus 9x. Now I can't figure out what number this is going to actually end up being because we don't know what x is and we don't know what y is. So I can't say like, oh, this is 62. Okay, but there is this equal sign. So because of that equal sign, that makes this an equation. Now this next one, number 3, can be a little tricky because it says -16 equals 4. Well, we know -16 and 4 are not the same. They're two very different numbers. But there is this equal sign. So because there is an equal sign, that means it is an equation. Okay. Number 4 This is our last one. This one we could figure out what does it equal. We could evaluate the expression. So we could say equals 66, but it doesn't have an equal sign there. So because there is no equal sign, this is an expression. Okay. All right, we're going to move on to the next page. So if you need to pause, pause. Okay. This next page, I'm going to be using a calculator. So I have my Desmos calculator pulled up. Remember, it's desmos.com/scientific. Or if you go to our Schoology page, it's right at the top. You can just click that Desmos. Okay, I have mine on presenter mode so that the picture or the numbers show up bigger. So if it looks a little different, that's why. All right, so for this one, we're going to determine if the following equations are true. So true means equal. False means that they're not actually the same. So that's that equal with that line through it. Or open. Open means we just aren't sure. We can't figure it out. Okay. I like to draw a line down my equal sign. That helps me keep sides. Whoops, that's a really terrible line. Okay, it helps me decide if the sides are going to be the same or different because we're comparing this side to this side. Okay, so to do this one here, we're going to decide, do we add first or multiply first? And we're going to multiply first. 12 times 2. Pause for a moment there. So 12 times 2 is 24. So I'm going to go back here, say this is 24. I haven't done that 3 plus yet, so I'm going to do 3 plus 24, 24, 25, 26, 27. So this is 27. Okay. What's really nice about Desmos, and I think you found that out during our order of operations video, is you can just type in this whole thing if you want to. We just have to be really careful. So it's 4 times 7 minus 3. And we just want to make sure it looks the same, and it does, and that's 25. Okay, so if this is 27, this is 25, they're not the same. So this is going to be a false equation because they're not equal. Okay. All right, number 6. So on this one I see I have parentheses. So because I have parentheses, I'm going to do that first. 6 plus 9. Whoops. See, this is what I'm talking about. We got to be careful. Okay, 6 plus 9 is 15. That 3 on the outside means to multiply, so 3 times 15 minus 4. So I'm going to do 3 times 15. So 3 times 15. Okay, and then I'm going to do minus 4. So rather than typing in 45, I'm going to use this A and S button. So I'm going to do answer. That just takes that 45, plugs it there. Minus, what was it, 4, I think? And we get 41. Okay, so that's 41. Okay, on this side I have 2 times x plus 7. So 2 times the quantity of x plus 7. So if we were going to simplify this, we would start by distributing 2 times x and then 2 times 7. So 2 times x would be 2x, and 2 times 7 is 14. Now, I can't do anything else because this has an x, this one doesn't. So I don't know if these are equal because I don't know what x is. If it said like x equals 4, I could try and figure it out, but we don't know. So this is going to be open because of that variable. We don't know. Okay, last one. We have 15 divided by 3 times 2 minus 4. So that's a lot. I'm going to just plug that all into my Desmos calculator. Okay, 15. So I'm going to make sure I'm on new line. 15 divided by 3. Now remember, division on the calculator goes underneath, so now I need to click over here. Times 2 minus 4. Okay, and that's 6. Okay, I'm going to hit enter, go to the next one. I have 2 times the quantity of 5 minus 2. So if we were going to do it by hand, we would do that 5 minus 2 first, which is 3. 2 times 3 is 6. So now this one, they're actually the same. They are equal. 6 and 6, they're the same. Okay, so that's going to be true. True equation means that it actually is equal. Okay, all right. Last part of our notes here, we're going to finish these equations. Okay, this one says finish the equation to make it true. So we need a number here where when I add 5 plus a number, it does equal -2. So if I do two positives, when I add, I'll get a positive answer. So I can't just do like 5 plus 9. That's going to give me a positive 14. So it's going to have to be a negative. And if I do like a -3, I still get a positive answer. I'd get positive 2. I need a -2. So I need a number that's bigger than 5 to get into those negatives. So let's try -6. That's -1. So I'm just going to delete that. -7. There's my -2. So if I put in a -7 here, that makes it a true equation. Remember, true means it actually equals. Okay. Number 9 says finish the equation to make it false. So false means we want it to not be the same. So the answer here is 24 on one side, and on the other side it says 2 times something. So we just need to put a number here that when we know we multiply it by 2, it does not equal 24. It's not the same. Okay, so we could do 2 times, I don't know, 26. Oh, that's 52. That doesn't work. Okay, so as long as it doesn't work because we want it to be false. Okay, we could also put in like 3,672. I don't know. Anything other than the right answer there. And the right answer, well, these are the right answers. It's confusing. But other than 12, 12 would make it true. Okay, so you could write down any number. We could do -4.32, so 4 and 32 hundredths. Okay, number 10, last one. It says finish the equation to make it open. Open means something that we're not going to be able to solve. Okay, that we won't be able to get down, well, not solve, that we'll be able to evaluate. We won't be able to get down to an actual number. Okay, so over here I have 16 plus 7 times -6. And here we have equals 3 minus something divided by 6. And we need to put something here that we're not going to be able to determine, so it needs to be something more than just a number. In order to do an open, we use a variable. So we're going to pick a letter, any letter. I'm going to use P because I have a water bottle with pineapples on it. So I pick P. We could put a number in front of it. We could do that coefficient. So we could do like 3P, 7P, 8P. 8P sounds good. So we're going to do 8P. Okay, but you could choose any letter here, any variable, because a variable is an unknown. And if you'd want to put in a coefficient, you could, but you couldn't just do 8. It has to have that variable. All right, take a little bit of some time, review the vocabulary, and decide what are your takeaways from this lesson. What are the big things that you understood or things you still have questions on?